Hello geometry students and welcome to lesson 6.5. Today we're going to look at the properties of special parallelograms, starting with the rhombus. A rhombus is a parallelogram with four congruent sides. So ABCD is a rhombus. What are I think a word's missing there. What are the measures of angles 1, 2, 3, and 4? So if we take a look at this diagram, right, look at the upper triangle ABC. B, we know, would be on the perpendicular bisector of that triangle. So since B and D are both on the perpendicular bisector of AC, we know that BD is perpendicular to AC. And that's again because B and D are both equidistant, right, to the endpoints of AC. So if they're perpendicular, then we know that each of these angles has a measure of 90 degrees. And that's an important fact to know because now we know we have four right triangles. Okay, letter B, the parallelogram JKLM is a rhombus. So how are those angles related? Okay, so in this diagram, we know that the triangles JKL and, whoops, went wrong way, JKL and JML are congruent by SSS. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So the diagonals of a rhombus bisect the angles at each vertex. We could draw in diagonal KM and show the same thing with the angles at M and the angles at K. Try it 1A. What is the length of WY? So go ahead and pause the video. Try this problem and actually try 1B while you're at it. And again, keep in mind that because this is a rhombus, and we know that because of the four congruent sides, we know that the diagonals are perpendicular to each other. So go ahead and pause the video and come back. Okay, let's see how you did. So hopefully for WY, you got a length of 8. And for the measure of angle RPS, hopefully you got 55 degrees. Right? We know the three angles in the triangle have to add up to 180. If we take 70 away, we're left with 110. And each of these angles are the same. And we know that they're the same on both sides of the diagonal. So RPS is 55. That brings us to theorems 616 and 617. So if a parallelogram is a rhombus, then its diagonals are perpendicular bisectors of each other. And the other theorem says if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So you can see in this diagram, 1 and 2 would be congruent, 5 and 6 are congruent, 3 and 4 are congruent, 7 and 8 are congruent. Example 2, finding lengths and angle measures in a rhombus. So I'd like you to go ahead and try these four problems. Okay, pause the video and come back when you're all done and we'll compare solutions. Okay, let's see how you did. For letter A, hopefully you got the measure of angle ADE is 37. For letter B, for GH, hopefully you got 16. And for angle MNO, hopefully you got 56 degrees. And for 2B, the length of QT is 8. So if you have questions about any of these, be sure to ask in class and we'll go over the work. So that brings us to theorem 618. If a parallelogram is a rectangle, then its diagonals are congruent. So what makes a parallelogram a rectangle? A rectangle is defined as a parallelogram with 4 right angles. So when I have 4 right angles, I know it's a rectangle. I know that in this case, AC is congruent to BD. So now you're actually going to prove that the diagonals of a rectangle are congruent. So we're given that PQRS is a rectangle. We're asked to prove that PR is congruent to QS. So I would like you to pause the video, fill out your 2-column proof, and I gave you a hint to use these 2 overlapping triangles. Okay, so go ahead and give that a try and then come back when you're done. Okay, let's see how you did. So we always start off with the given. Okay, we can say that PQRS is a parallelogram. And then we can state that PS is congruent to QR because they are opposite sides of a parallelogram. PSR and QRS are right angles. That's also by definition of a rectangle. That makes those angles congruent because all right angles are congruent. We can say SR is congruent to itself by the reflexive property. Therefore, we have congruent triangles by SAS. We can then say that PR is congruent to QS by CPCTC. Okay, so what I'd like you to do is try these 4 examples. Pause the video and then come back when you're done. Okay, let's see how you did. So we have diagonals of 52 inches and 53 inches. Those diagonals need to be congruent, right? So if they're not congruent, we don't have a rectangle. In example 4, did Paul make his goal? He ran at about 4.4 meters per second, so yes, he did. A rectangle with area 1600 meters squared is 4 times as long as it is wide, so what's the sum of the diagonals? Approximately 165 meters. And the perimeter of the butterfly garden. Hopefully you came up with about 349 feet. So again, if you have any questions about any of these examples, please ask in class and we'll go over them. Example 5 has to do with the square. Now, the square is the most special of all the parallelograms because a square is a rhombus and it's a rectangle. So it has 4 congruent sides and it has 4 right angles. So knowing that, pause the video, go ahead and try example 5, where you're asked to figure out the area of YPZ, and then try it number 5 as well. Come back when you're done. Okay, let's take a look. So hopefully you came up with 264.5 square units. And for try it number 5, hopefully you came up with 45 degrees. If not, again, ask in class and we'll go over these examples. Okay, from the concept summary, if we have a rectangle, right, then we know that the diagonals are congruent. If we have a rhombus, then we know the diagonals are perpendicular and that they bisect each pair of opposite angles. If we have a square, remember the square has all of these properties. So the diagonals are congruent, the diagonals are perpendicular, the diagonals bisect the angles. So again, the square is the most special of all the parallelograms. So that concludes our lesson on the properties of special parallelograms. I hope you enjoyed it, and I'll see you in class. Have a good day.